Since 1992, DW Fern mic preamps, equalizers, and compressors have been used in some of the world's best studios, as well as in private use and home studios around the world. This tutorial will help you get the most from your DW Fern products. Learn what each control does and see the best setup starting points for a variety of recording situations. Learn how to interface our products with the rest of your studio gear. Take a peek inside to see how our products are made, and learn from Doug Fern's experience in over 40 years in pro audio.
Back in the 1960s, if you wanted to record an electric bass guitar or other electric instrument directly into the recording system, you built what was called a direct box. This was a very simple device consisting of an audio transformer, usually made by UTC, a 1/4-inch jack for the instrument to plug into, and an XLR connector for your mic cable that went to your console or mic preamp. You put all this in a metal box and lived on the floor in the studio, and that was your direct box. Thousands of wonderful records were made that way, and they sound great to this day. So that works pretty well. Actually, it works very well for bass guitar. It doesn't work so well for electric guitars. And after a while, people realized that they could do better with direct recording by using what we called an active direct box, which used generally a solid state stage instead of a transformer to provide a better load to the electric instrument than the transformer alone. Later on, when I developed the VT-1 mic preamp in 1993, people asked me why it didn't have an instrument input, because some of the other mic preamps out there did have that feature. So I decided to see if we could add an instrument input to the VT-1. And I started out by talking to the manufacturers of custom guitar pickups, trying to find out from them exactly what kind of load impedance and other characteristics their pickups were designed to work into. And I also studied the schematics of a lot of guitar amps, the Fenders and the Gibson and Marshall and Ampeg amps, to see how the designers did that, because after all, a company like Fender, who made the guitars and the amplifiers, probably knew best how to interface the two. And in addition to that, even if they weren't properly interfaced, that became the standard. That became the sound of the instrument. So after looking at all that, I said, well, could probably change the VT-1 mic preamp input stage to accommodate an instrument input. So I tried that and it worked okay, but I found that it wasn't optimal. It took a little bit of playing around with the circuit and changing values and different things in the mic preamp in order to make it a really good DI input, a direct input, an instrument input. It seems like the VT-1 could either be a really great mic preamp or a really great instrument input, but it couldn't do both. And the switching required to switch it from one to the other was just way too complex and would introduce all kinds of new problems into the design. I didn't want to compromise on the VT-1. It was the best mic preamp I knew how to build, and I did not want to junk it up with a lot of stuff that was going to compromise the performance. So I gave up on that approach and decided, well, I've done all this research. Let's build a separate standalone vacuum tube direct box, or DI. Now, DI is a term I think originated in England, stands for direct injection or direct interface, which sounds a little more elegant than direct box, so I kind of prefer that term, but they're all the same thing. So I took what I learned and I built what became the VTIF. The VTIF is a 2-channel DI, all vacuum tube, and it turned out to be a very heavy, robust, expensive device. It's heavy and robust because it's made out of 1/4-inch machined aluminum instead of sheet metal, and it's very heavy. And because of all that metal and all that machining that goes into it, it was very expensive to build. And we sold them when it was first introduced in the early 1990s for $1,500, which really was not much over our cost. The box alone cost us over $600. So it really was not a practical product, but I felt good about it because I thought it advanced the art and provided recordists with a tool that was probably as good or better than anything else like it they could find. We didn't make too many of them, but we sold all of them that we could make, and there was a total production run of about 75. And the people that bought them loved them and continue to use them to this day. I have one that I made up out of rejected metalwork that had blemishes in the paint and so on that I couldn't use to sell to a customer. And I use it all the time myself, and it works great. But it wasn't really a practical product. So to replace that, we came out with the PDB, the Passive Direct Box. This is, like the name implies, a passive device, not active. It uses a Jensen direct box transformer and some additional components in there, including a ground lift switch and so on, which makes it about as good as you can get in a passive DI. And we've sold many, many hundreds of those. But I still was disappointed that it didn't quite come up to the standards that I had set with the VTIF. So I decided to design a new version of the VTIF using the same circuit, same components, but packaged differently so it wouldn't be as expensive. And the result was the VT3. The VT3 is a rack-mounted version of the VTIF, has a couple of extra features that the VTIF did not have, but otherwise it's identical. Now, I have a soft spot for the VTIF because I like the way it looks. It's a very practical device because for many studio situations, you want your DI to be out in the studio with the musicians. You can't run a guitar amp, bass amp cord for more than about 20 feet before you really started to run into signal degradation problems. So the DI has to be close to the instrument. Now, if you're recording in all in one room, especially if you're just recording yourself, that's not a big problem, and the VT3 is probably a great solution. It has all the connectors you need right on the front panel, plus it has additional outputs on the back panel, so that if you don't want to clutter up your rack with XLR cables hanging off of the inputs, the outputs of the VT3, you can connect it in the back instead. And that's a good solution for a lot of people. We might bring back the VTIF if there was sufficient interest. We've had them on the road with touring bands we've used them for years. They've gone through an incredible amount of abuse, fallen off loading docks, and they continue to perform really well. Let's look at a little bit of the fundamentals involved here so you have a little bit of insight into how to get the most out of your DI, whether it's one of ours or somebody else's, and get your instrument recording sounding as good as they can be. First of all, why would you want to record an instrument direct? I mean, a lot of times, especially with electric guitar, the guitar and amplifier form a system, and the sound that the guitarist wants is comprised of not only the settings and the way they play the guitar, but also with the amplifier. Also, when you have a guitar amplifier in the room, you can utilize some of that room sound, which can enhance the sound significantly. Something like a bass, though, usually doesn't sound so great coming through a bass amp. There are exceptions. There's times when you'll prefer the sound of a bass amp with a microphone on it. But usually bass sounds best taken direct. Well, let's look at the way these instruments produce their output and how we can interface that with our recording equipment. A guitar bass pickup consists of a magnet that's been wound with many, many turns of very fine wire. These are placed underneath the strings so that when the string vibrates, it actually changes the magnetic field that exists in that magnet and coil of wire. That generates a very small voltage, which then needs to be amplified. The output of the guitar bass pickup usually goes through a volume control, maybe some tone controls, maybe some switching or another pot if there's more than one pickup so that you can choose or blend the two. And from there, it comes out of the instrument on a 1/4-inch jack. Now, this is an unbalanced output. It was done that way probably in the 1930s when this system was first developed because it was inexpensive and easily done. Transformers back then were extremely expensive. Not that they're cheap today, but they were much more expensive back then for high quality transformers, and it really wasn't necessary. If the guitar player was standing right in front of his amp, he could get by with a 10-foot cord to the amp, and it wasn't a big deal. But unbalanced high impedance signals like that can't travel very far. And the problem is the cable that connects the instrument to the amplifier has a certain amount of capacitance in the cable. This is caused by the construction of the inner conductor and the shield. It's an inevitable consequence of any cable. And in professional systems where you use low impedance balanced cables, the capacitance is an issue, but not a great one, and you can run hundreds of feet, maybe even thousands of feet of mic cable without any significant loss in the quality of the signal. That's not true with a guitar output or bass output. The high impedance means that it's much more sensitive to that capacitance. So a 20-foot cable is about the maximum. You put 50 feet of cable on there and you'll definitely hear a loss in the high frequencies. Another problem with unbalanced circuits like that is their susceptibility to noise. You know, anybody that's ever played an electric guitar in a room with fluorescent lights knows the problem. The guitar pickup is not only sensitive to the vibration of the string, but it's also sensitive to any other electrical fields in the vicinity. They don't have to be very strong to cause interference that you can hear. That's why most guitars have a certain amount of buzz that's there all the time. Most of that noise consists of the 60 or 50 hertz AC mains signal that exists all around us with the wiring in our homes or studios, plus all the harmonics of that. And what you end up with is a raucous, very discordant sounding buzz that can be very annoying and really makes a recording unusable if you have that kind of noise on it. So it's important to keep the length of the cable between the instrument and the amp or the DI as short and direct as possible. You also have to be careful about the electrical environment that you're working in to make sure that you don't have fluorescent lights that generate a lot of noise or lights on dimmers. Most of the cheap household type dimmers create a tremendous amount of noise, which is very similar to that buzz that you hear in your guitar signal. And that kind of a dimmer is usually not a good thing to use in the vicinity of any recording equipment, but electric guitars are particularly susceptible to that. So we want to keep the connection short and direct. After I developed the prototype of what would become the VTIF, I invited a friend of mine who played a lot of instruments over to help me try it out. The first thing he plugged in was a Gibson 335, which is a big hollow body guitar, which actually is one of the few guitars that tends to sound pretty good taken direct compared to solid body guitars. He plugged that in and we turned everything up and he strummed a few chords and did some little runs and stuff, and it sounded really nice. So we unplugged that and we plugged in his Fender Precision bass, and that sounded great. It was really full. It really didn't need anything else. I mean, the sound of that instrument directly through the VTIF and then into a VT2 sounded just right. And the next thing he plugged in was a Martin D35, which had built-in pickup. And we connected that, and that sounded pretty good. It didn't sound as good as the instrument mic'd, but it sounded fine. And then he pulled out a Fender Strat. Now, the Stratocaster is a classic solid body guitar. And my experience in the past had been if you try to record a Strat direct, it sounded pretty much like a banjo. I mean, that's an instrument with a tremendous amount of power and dynamic range, and and fatness to it. And yet, when you plugged it into any kind of a transformer direct box, a passive DI, it suddenly just sounded small and tinny and absolutely useless. Well, we plugged in the Strat, not hoping for much, and he's tuning it up and adjusting the controls, and I'm playing around with a VTIF, and then he starts playing some stuff, and it's sounding nice, and we're sort of enjoying the little riff he's playing. And then suddenly he stops, and we both look at each other, and we look at the speaker, because we were just using a studio monitor speaker to listen to this, and we were both amazed, because what it sounded like was a Strat going into a great Fender amp, like a Fender Twin Reverb or something like that. Very, very clean, but had that same kind of sound. And we were both just quite amazed at how good it sounded. And I thought, well, maybe we're really on to something here. I mentioned earlier the ground buzz that you often hear with electric instruments. It can be coming out of the amp that way, or it could be something that was created in your interface with a DI. And one of the reasons for that is because, especially if you're connecting your direct box both to the instrument and the amplifier, and then taking a feed off to the recording equipment, it's entirely possible that the amplifier AC mains feed is a different one than the one in the control room where your recording equipment is connected. Even if it is the same feed, sometimes the length of wire between the two is enough to create what we call a ground loop. This is just a extraneous noise. It's the same kind of buzz you get from your electric guitar standing under the fluorescent light. Maybe a little purer sounding, but it's still annoying and unusable. And that's one of the reasons why many direct boxes and DIs have what they call a ground lift switch. And you can see on here the VT3 has a ground lift switch on both of the channels. And what this does is it disconnects the ground side of the output of the VT3, the side that goes to your mic preamp. It disconnects that ground lead, and that breaks the ground loop. And that can often solve the problem. Now, if your guitar amp also has a ground switch on it, as many of the older ones do, sometimes you can try different combinations. There's a multiple combinations between where this goes and where the switch on the amplifier goes. Try them all and find the one that's the quietest, and that's the right position for recording. Now, if you're taking an instrument direct without using an amplifier as well, then probably the ground lift switch isn't going to make a whole lot of difference. If it does, that probably indicates something else is wrong. But the ground lift switch is used in those cases where you're actually feeding the amplifier as well as feeding the DI. And that's why there's two jacks on each input. One is labeled instrument, and that's the one that you plug your guitar into. And the other one's labeled amp, and that's the one that has another guitar cord that comes out of there and goes into your amplifier. That allows you to have both the direct feed and the amp active at the same time. Now, these two jacks actually are interchangeable. You could plug them in either way. They're just connected in parallel. Why would you want to do that? Well, there's a couple reasons. One is if the player wants to play along with others, he may need that amp as part of the sound that the ensemble's trying to create. So in that case, the amplifier is necessary. The second possibility is that you might want to use both the direct feed and a microphone in front of the amplifier. Now, personally, I don't find that very useful most of the time. I think you should pick one or the other, whichever sounds better, and use that, because chances are there's going to be some random phase difference between the two that's going to cause problems down the road. Use one or use the other. Record them both if you want to, so you have the option later, but I find it's usually not useful to mix the two together in the final mix. Another possibility is that you might want to use that amp and just a room mic far away, 20, 30, 50 feet away, and that can add a certain quality to the sound of the electric guitar particularly. So that's what that ground lift switch is for, and that's what those two jacks are for. There's one other switch on here labeled HPF for high pass filter. And this switch is used to introduce a filter in the output of the VT3, which rolls off frequencies below about 150 hertz. Now that wouldn't be too useful if you're recording bass guitar, although who knows, you might find some combination of settings on the bass, tone controls and so on with the VT3 high pass filter that creates a sound exactly what you're looking for. But chances are it's not going to be useful on a bass. It could be more useful on a guitar, particularly a solo part where you don't need the lows, or on a keyboard in the same situation. So it's not the kind of thing you're going to use every day, probably, but it is there if you need it, and it will allow you to roll off some of the extreme low end of the instrument. So how does the VT3 sound? Well, if you want to take a listen to it, go to the video tutorials that describe the VT7, VT5 on the mix bus, and take a listen to the last two tunes on there. On that recording, all the electric instruments were recorded direct. No amps were used at all. They all went through a VT3 or VT-IF, and you can hear for yourself what it sounds like. You'll hear bass guitar, you'll hear electric guitars, several of them, and several different keyboards. So to give you a sense of what the VT3 sounds like. The VT3 is our current production DI. It's an all vacuum tube design with two separate channels you can use independently on two different instruments, or if you need it, on a stereo instrument like a keyboard. We also make the Passive Direct Box, the PDB, which is similar. It's a single channel, a lot less expensive, but about as good as you can get in a passive direct box. The VT-IF has been out of production for a number of years, but if there's enough interest in it, I'd love to start producing that again, because I think it's just a terrific device for use in the studio.